Good evening. Welcome to Space Oddities. Thank you so much for giving up some of your Boxing Day to be with us. Hope you're having a wonderful Christmas with your family and friends, and that you're really enjoying yourselves. And as I said, thank you so much for being here. We do appreciate it. Well, we're a bit thin on the ground tonight, as one might reasonably expect, being Christmas. So I'm delighted to be joined by Michael and Roger. How are you both? Have you had a good Christmas?
Fine, thank you. Excellent Christmas, thank you.
Pretty good, pretty good.
Sorry, Roger, come on.
No, done quite nicely, thank you.
Good, good. We're also joined now by Daz. How are you, Daz?
I'm fine, thank you. Hope everyone had a lovely holiday, and we're all looking forward to reminiscing about the past
Yes,
12
indeed.
months.
So this evening you joined us, and we're going to do a review of the year in space, looking at some of the great things that have been happening in space exploration and astronomy this year. So stick with us for the next hour or so, and we'll take a look back at the year in space in 2022. Excuse me. But of course, no Space Odyssey show would be complete without the man with the maps, and who's Roger, of course. Roger, what's been going on this year or this week in the skies? What have we got?
Well, of course. We continue on with our odyssey through the week of what's in the night sky, and as everyone is aware, we've got a growing crescent moon, which will be first quarter in the.
Your presentation appears to just here. 1 second, I will get that back for you.
Oh, there.
There we are. There we are.
Stuff, right. So on Thursday we've got the first quarter, which will won't be too disheartening for astro imagers. But I had another go at the Horsehead while the moon was reasonably out the way, and managed to get a better image this time.
That's really good, Roger.
Oh, wow. That's really good, Roger.
Now that was only 2 hours this time. The other one was 90 minutes, but this was, I think I had clearer visibility this time, and with only 2 hours, it's come out rather fab. I'm quite pleased with that. So
I've had that on the wall, Roger.
Yeah, not too bad. Although Alnitak's not too blown out, I think I'd probably be better to put it on a proper mount and put the exposure a bit longer and the gain down a bit, so he's getting quite so blown out with Alnitak. But it's okay. I think I'll work my way around the sky after having a few goes at that. So but I'll come back to it. I'll come back at another. And here's what the moon's looking like as we speak, although it's almost set now. But it is quite low at the moment. But
yeah, I saw that earlier.
And if you notice, you might have spotted Saturn above it. And if you were really lucky and had a low down horizon, you might have spotted Mercury shortly after sundown. So that's one to look out for. Although it is at its current highest from the sun. So around about now is the best time to try and spot Mercury low down on the horizon shortly after sunset. So keep an eye out for that. But we've still got Saturn for a little while longer, and obviously Mars and Jupiter are still dominating. Jupiter less so now, but Mars is looking absolutely fantastic over in Taurus, and it gets really, really high up in the night sky. As you can see from the maps, which are all at 10 p.m. GMT time, and Orion is now dominating the night sky quite nicely. And if you're interested in any other objects like myself, I'm going to be trying to do the Horsehead, the Witch Head down near Rigel at some point. So
good luck with that.
Clear skies with that, and I can probably just because it's such a large object, you can probably do it with a telephoto lens on the camera, which is what I shall try and do, because my even my 71mm William optics is probably a bit too long focal wise. But There we go. So I've got some selections of images from the last 12 months here of what the James Webb Space Telescope has been showing us in all its glorious near-infrared and infrared imaging that we are now getting accustomed to. This is the most recent one, which is showing some various hydrogen outflows from part of one of the images that we were presented with earlier on in the year, but we're obviously still getting a lot of information back with all the data that it's trying to send to us, and we just can't keep up with it. It's just absolutely amazing.
These are outflows from very young stars, maybe less than 1 million years old, that are very active and very hot. And what's been a big surprise about these outflows is that there are so many of them. And there are so many coming from stars within this image that it really does indicate that all the stars are more or less exactly the same age. So they formed all at once in the Carina Nebula, which is absolutely amazing. And they promise to teach us a lot about the evolution of young stars.
Yeah, because usually when you look at globular clusters and things like that, the stars are all the same age. You take the Pleiades, and those stars are all the same. But of course, right next door, you've got the Hades cluster, which again were a group of cluster stars that were formed at roughly about the same time. But they have now spread so far apart, there is a chance that it won't even be considered as an open cluster. At the moment. So it's it is fantastic. I mean, these images, as you said, the expulsion of the gas out of the nebula by these young stars as they're coming into life is fantastic. And of course, we couldn't see any of this with Hubble because it was absorbed by gas, and to see them in their little cocoons is amazing. And we've got more to come.
Yes.
Yeah. Of course, you got the highlighted images of 1, 2, and 3, which have had the stars taken out to focus on the amounts of gas that they are.
That's a lot of gas.
Yes.
A lot of molecular hydrogen.
Oh. Anyway, so we've also got the measurements of the amount of redshift from various objects which has been spotted, and the highest redshift is 13.2 on there. So I don't know exactly what the distance is for these objects to be, but obviously back to the earliest times of the actual creation from the Big Bang. So
well, they're saying now that it was in the news and it was misrepresented in the media about these really, really old galaxies, and people were saying it disproves the Big Bang and all this nonsense. But astronomers have recently tentatively, and put that in capital letters, tentatively confirmed that some of these galaxies that Webb has been showing us. Do you remember the first SMACS image with all that lovely gravitational lensing? Well, in that image, there are some galaxies that are showing a redshift of 20. And that equates to 150 million years after the Big Bang. So these are the earliest galaxies seen. Not only that, they're much earlier than we thought the Webb was capable of seeing. And also, of course, they're much more fully formed than anything 150 million years after the Big Bang should be. So the Webb has really, really posed some head-scratching questions about the evolution of galaxies that appear to be evolving much earlier in the history of the universe than we thought. But then that's no surprise, because we knew our knowledge of galaxy formation is very sketchy. It's not surprised that Webb has thrown up loads of questions, and that's really part of its mission. But it does raise some interesting questions about how fast galaxies evolved after the Big Bang.
Surely,
There
if
was
after the creation from about 150 million years, surely these galaxies would be extremely small for that short period of time for the galaxies to be created.
You would think so, wouldn't you? And the fact that Webb has managed to detect them is interesting.
Yes.
But as I said, this is a
Yeah, 'cause
tentative confirmation. It's yet to be absolutely confirmed that they do have this high redshift.
Yeah, because there was one image that it's taking, and it's the most distant quasar. And I'm just trying to find the number of it. It's really a romantic name. I can't find it off of the cell at the moment. But it is actually a quasar. At first, they thought it was a quasar, was highly interacting with big jets because it was merging with this was with Hubble, was merging with another galaxy. But what they've actually found out with Webb is that there's actually 3 galaxies circling this one other galaxy with the a black hole inside it. So this is why it's so gigantic. And if I remember rightly, it's about 11 billion years old. Yeah. So oh yes, here we are. It's a quasar, and this is a lovely. I really love this name, SDSS J165202.64 plus 172852.3. I mean, it's poetic. It's
Trips
poetic.
off the tongue, doesn't it?
It really does. But it's actually found that it's 3 galaxies circling this one galaxy.
Really?
And of course, as you said, Andy, they found now that the galaxies they thought would all be irregular and things like that, but they're actually spirals. And why are spirals forming so early? It's amazing what we're finding, and it's what we're going to actually find. We're going to find questions we didn't even know that we had to ask. So it's going to be fantastic.
Yeah, Jack's come up with a question for you, Roger, which I'll put up here. Can you explain the graph on the right? I think he was referring to this. Yes, is it a spectrum? Yes, it is.
It is a type of spectrum.
Yeah,
Yes,
it is. Yeah, yes, Jack. It's a spectroscopy, and it shows the wavelength of light and the prevalence of it, basically where it's peaking. So it's going from low frequency to high frequency, and effectively it's a spectrum of light. Yes, effectively.
Yeah. If Jack wants to know a bit more about spectroscopy, then I have done on the Space Oddities site, a YouTube site. I have actually done a spectroscopy video, so you might be able to learn a little bit more about it there, Jack. Go along and have a look and see what you feel.
Yeah, don't forget, viewers, that we do have other videos that we've done apart from our live show. So check out our channel and the playlists on our YouTube channel. And Daz actually has been studying for quite a long time now how to say the word spectroscopy, and he appears to have mastered it now. So well done, Daz. Did you go on a course?
Oh, there you go. Look, so you've ruined it now. I'm not going to be able to say it now, am I? Spectrographic, spectroscopy, it's analysis.
You get in there. You get in there. Anyway, sorry, Roger. Sorry to interrupt.
That's all right. That's all right. Here's a breakdown of one of the panels of pictures that the Webb has collected, and it gives you a breakdown of all the different shapes and sizes of galaxies all over the place.
That's amazing, isn't it?
Spiral, elliptical, irregular, you name it, it's there. So it's quite interesting to see that such a conglomeration of different shapes and sizes are all pretty much packed into this one few panels of pictures, really, with quasars and all sorts of.
The variation is amazing, isn't it?
I'm sure they'll have to make some new categories up, I would have thought.
Well, it does appear so, doesn't it? Because some of these are really strange.
Yes. Most unusual, but there we are. And then, of course, we've got one of our favourites, the Pillars of Creation. And this is just an amazing image. Absolutely amazing. And then, of course, we've got our own little collection of images that were done in our own solar system here, and some interesting details from one of the moons here, with some detail, hopefully, if they've calculated it right, that will give us more inspiration to visit this moon. We'll see. Have to wait and see on that. I would have thought.
Yeah.
Absolutely. And
Quite a lot of us would be interested in a close flyby and maybe pass through the atmosphere to see what can be photographed towards the surface of this wondrous moon.
I know for a fact that Michael's going to talk a little bit later about Dragonfly, which is the mission to explore Titan. The whatever you want to call it, helicopter, drone. I'm not sure what we should call it, but it's a flying vehicle that's going to be exploring Saturn's moon Titan, which is the second largest moon in the solar system. Over, of course, well, they're hoping the mission will last for a couple of years, of course, but it's not launching until the end of this decade, and I think it will get to Titan in 2034, if I remember rightly. So we've got a while to wait before we actually see Titan from the surface.
And here we've got the Southern Ring Nebula, I believe, which was of quite interest, and those almost solar prominence flares that are spreading away from the main construction of that gas. So it is absolutely amazing.
Look at that!
And then we've got the butterfly, haven't we?
Yes. Such a pretty butterfly.
That's a pretty butterfly, absolutely.
And the one previous to that, Rog, was that the one where it's the first time the star at the centre has ever actually been seen?
Probably was, yes, Daz. Yes.
Because I mean, when you look at the frills around the edges, what I call the lacy frills, you can see they're actually pulsating. So there is possibly a good chance that it's in a binary system. And it's the actual effect of the second star orbiting the first star, which has caused these sort of like lines, these waves coming out on the frilly bits at the end. I mean, I could be wrong, but I've seen it before, and it just looks as though that's what it could be. It's a fantastic image, as you said.
Absolutely. Beautiful. Right. And of course, we've got this one, which is one of the earlier images that we've all come to know of the deep sky filled image that has only taken a fraction of the time that poor old Hubble used to do. So how amazing it all is to. And here's an earlier version of the
pillars of creation. Amazing. Oh, yes.
And this one. Yes, we've got the old rings here. The tree ring effect from that was from the orbiting star, which was causing that, was it, Andy?
Yes, it's a binary system where I think it was every 3.5 years, they have a bit of an interaction, and this causes great quantities of dust to be released as they pass by each other, and it manifests itself in their orbits as these rings. So if you think that each one of those rings, well, the rings are separated by 3.5 years. I think it was 3.5 years. So you can see how long this has been going on. And we're not seeing the full extent of those rings either, obviously. So it's quite amazing, absolutely amazing. And many people thought this was a fake image, that it was some sort of artifact from the sensors or the processing. But this is an actual image of a binary system where these rings have been caused by the two stars interacting. Amazing.
Yes, and of course, it's the dust that's being excited that we're actually being able to see this. this effect. Isn't it a Wolf Riot star?
Yes, it is. It's a Wolf Riot star, so very active hot star.
And here we have one of the multiple effects of the gravitational lens in here. And this one's shown to quite a good effect with the amount of distortion that's pulled around that object. And oh, here we got a tarantula nebula, which looks rather fantastic with all those blue stars down near the center here. Although we shall never get to see it as well as the James Webb. And of course, one of my favorites, here's the one which was earlier shown, but to its full extent of what was captured.
Beautiful.
Absolutely.
And our own very own Mary McIntyre has done a beautiful sketch of that, which is quite wonderful.
Yes.
Yeah, it's really lovely.
Here we have the Cartwheel Galaxy.
Yeah.
With a few other interacting galaxies as well. And all dozens and dozens in the background also captured.
Yeah.
And here
I mean, looking at the
that's the one I was talking about, where these incredibly young galaxies are in the SMACS image.
Yeah.
Just think, I mean, that was its first image, and just look at how many questions it's raised just with its first image. And of course, we're only a few months into science operations of the Webb. The Webb has possibly got 20 years ahead of it in operation, if all goes well. What are we going to learn over those 20 years? You just can't imagine what we're going to learn. It's just so exciting.
And another one of the early...
Sorry, there's a question just popped up in the chat from Ian McIntyre when we were talking about Titan.
Yeah, I've just answered
and about the helicopter. Oh, sorry. Okay, sorry.
Yeah.
Now, obviously, with the southern ring, you can see the binary system in the center of the disk here. So
you can see it very clearly in the infrared, can't you?
Rather more obvious in this image here. Yes.
Yes, because the northern ring, it's quite a faint, insignificant star, really, isn't it? You can see it, but it's not incredibly obvious. Which is the progenitor star for the nebula.
And you can see the star colorations of the two individual stars as well to compare them. And then we've got Stephen's quintet.
I love that image.
Yeah,
it's
amazing.
Beautiful, mysterious, everything. It's amazing.
Really.
Great. Okay. Thank you very much indeed for that.
No problem.
And what we're going to do now, we're going to go straight over to our review of the year. And if you have any questions or you don't want to make any points, guys, please put them in the chat. We will do our best to answer any questions that you have. So just let me set this up for 1 second. And let's see how we get on with this. Okay. So this was the year in space in 2022. I'm sure you all recognise the image, so I won't bore you with that. One thing we need to do, though, is we need to dig Daz out from behind. Oh no, who's behind I'm behind the snowdrift. Oh, that's okay. So I would just leave me there for now. I will just turn that off though, and find where I put it. There we are. There we are. Okay, so this was the year in space 2022. In April, we had the first ever completely private mission to the International Space Station. This was the Axiom 1 mission. And does anybody want to talk about that? No? Okay. The Axiom 1 mission is the first in a series of missions that has been bought basically by a billionaire. And the idea is that Axiom, the company, are going to build their own space station, and it will grow as part of the International Space Station and then detach from the International Space Station and become a free-flying space station in its own right, if you like. The technology behind it is amazing. And this first mission was really just to acclimatize the astronauts to spaceflight and working in low gravity environments. The Axiom 2 mission is planned for. Does anybody remember when the Axiom 2 mission is? I think it's coming up.
February.
First quarter.
Yeah, first quarter, I think. Yeah.
Yeah.
But they should start. Well, according to their plans, they should start constructing their own space station by, I think, the end of next year. No, I think end of 2023. They said. So we've got lots of interesting stuff to look forward to with Axiom. This was not a space tourism flight that was inevitably put all over the media. This was to actually do productive things in space, and they did lots of experiments as well while they were on the space station. Then in May, we had the second test flight of Boeing's Starliner vehicle, which obviously has had a lot of problems, and it went off more or less all right. There were problems with the thrusters when it was trying to dock with the space station, and they had another, a list of things that did go wrong, but nothing that would or ended up putting the mission in jeopardy. The Starliner, as we know from Boeing, has been a disaster. They're never going to make any money on it. It's a real disaster, and it's only probably going to fly fewer than 3 flights when it's certified for human spaceflight, because I think in April, if I remember rightly, will be the first crewed mission on the Boeing Starliner to ferry astronauts to the space station. I wouldn't want to be on that, to be quite honest. What do you guys think?
Well, yeah.
No, that's a definite no.
Yeah.
I think it's.
But isn't it like the private space stations as well?
Yes, absolutely. But Boeing have made many huge errors. I think we were talking about this last week. So anyway, that was the second test flight of the Starliner in May. Didn't go entirely to plan, so we'll have to see what happens. And then moving on, we have the Blue Shepard flew a few times this year from Blue Origin, of course, in March, June, and August. And there's not much to say except it was the usual tourist flights where they just go up to the edge of space and come back down again, all in a few minutes. Of course, they did have a major disaster this year. Well, not a major disaster, but a potentially major disaster, where the capsule had to abort from the booster because of an engine problem. And it proved the escape system worked, but not looking good for Blue Shepard at the moment. And the results of the final inquiry into what happened hadn't been made public yet. So there we are. Then, of course, moving on, in September, we had another flyby of Jupiter from NASA's Juno probe. This was flyby number 47 of Jupiter, and here's one of the images of Jupiter from the flyby. But also, interestingly, in September, Juno flew by Europa. And this is one of Kevin Gill's processed images. If you haven't seen what Kevin Gill can do, check him out on Flickr. Certainly, I know he's on Flickr. He produces the most amazing processed images. And the flyby went totally to plan. And we ended up with these lovely images of Europa, which, of course, we haven't seen close up since Voyager. So it was great to see Europa close up again. And we shall look forward to more from Juno this year. Then, also in September, we had, of course, I think what everybody will remember from this year in terms of missions, the DART mission, to try and see whether we could deflect the path of an asteroid that might be threatening the Earth. And in this case, it was the asteroid Dimorphos, which is a moon of the asteroid Didymos. So they're 2 asteroids, one orbiting the other. And NASA just basically slammed the DART spacecraft into Dimorphos to see whether we could deflect its path. Now, neither of these asteroids pose or will pose any threat to the Earth in the near future. So this was just a test to see if we were threatened by an asteroid, what we could actually do about it. And of course, the thing about this is that it could happen at any time that we might be threatened by an asteroid we knew nothing about. So let's just run this. This was just the video of the DART spacecraft approaching the little asteroid.
Starting to see those individual boulders there. You can see shadows of the various rocks on the surface.
It's amazing, guys. Oh my goodness, look at that. Unbelievable.
Yeah. Looks to me like we're headed straight in. Oh my gosh. Oh wow.
Yeah. Oh my goodness. 8,
Yeah.
7, 6,
wow.
5, 4, 3, 2, 1.
Oh my gosh. Oh wow. Visual confirmation. All right. We got it. Ready?
And we have humanity for humanity in the name of planetary defense.
Fantastic. Oh, fantastic.
What a moment. Very few words can really capture this moment. This is beautiful to watch.
So this was the actual impact as seen by the Hubble Space Telescope, the moment when the DART spacecraft slammed into Dimorphos, and it had a really unexpected effect. And that is to say, if we look at this image, again from Hubble, and there's a little bit of an animation here of the impact itself, or just after the impact, you can see the amount of debris that's being thrown up by the impact. And in the event, what happened was that this trail of debris was left behind by the spacecraft's impact. Now, this debris was reckoned to be about 1,000 tons in total, and this does indicate that Dimorphos was a lot more loosely packed and granular than we had thought, that the spacecraft impact was able to lift 1,000 tons of material off the asteroid. And this trailed out behind the asteroid like a comet tail, basically. It does remind one somewhat of a comet. And the answer was that yes, we managed to deflect the asteroid Dimorphos so that it now takes less time to orbit Didymos. So we know that we can actually deflect asteroids from their paths with an impact. But of course, how successful that will be will depend obviously on the asteroid in question and its composition and its velocity and everything else. But this was a very successful first test of planetary defense. So congratulations to NASA for that amazing mission. It's certainly the mission that sticks out in my mind for this year. In November, we had the launch of the Capstone mission. The Capstone mission is designed to test an orbit around the moon that will be used by the Gateway space station, which is part of NASA's Artemis project. The Gateway will be a small space station orbiting the moon, and they wanted to find out whether the orbit they had planned for it would actually work. Capstone is testing that orbit, which is known as a halo rectilinear orbit, quite a complicated orbit, elliptical orbit around the moon that they want for the Gateway when it's if and when they build it in lunar orbit as a sort of a base for astronauts exploring the surface. So we got that to look forward to. In December, we had this image again from Juno. And this is an image of Jupiter's moon Io in the infrared, because Juno does have some infrared capabilities. And the glowing bits are lava lakes from Io's more than 200 active volcanoes. And it's amazing to see these glowing in the infrared, because obviously they are very hot. That's all lava glowing on the surface of Io. And lastly, in December, we had the launch by SpaceX of the Japanese Hakuto lunar lander and the Lunar Flashlight spacecraft. Both were on the same SpaceX launch. The Hakuto lander will be a testbed for various technologies. The Lunar Flashlight will actually be used for examining whether there is indeed ice on the surface in those craters at the south pole of the moon that are never touched by the sun. And it's reckoned that there could be large quantities of ice just lying on the surface where the sun never reaches. The Lunar Flashlight spacecraft will beam an infrared laser down into those craters and to see if there's any sign. We know the ice is there, but it's a question of, is it on the surface or is it deep underground? And the Lunar Flashlight will help us answer that, because obviously that would be very useful for lunar explorers if there's ice lying about on the ground. So there we are. Now, also this year, China has made great strides forward in space. They have completed, for the moment, their Tiangong space station. They've added 2 new lab modules this year, and China is going from strength to strength in space. SpaceX have had a very successful year. They're on target to have completed 62 launches in 2022. That's exactly double the amount they launched in 2021. And already for 2023, they've got projected 52 launches. And obviously that will increase. They've had a good year, SpaceX. They've mainly been using the time to work towards the first orbital attempt of the Starship vehicle. This year we got to see the so-called chopsticks in use for the first time, which will be used for stacking and unstacking the Starship itself from the massive super heavy booster. And this is just a video showing oh, that wasn't a video. That's one's gone. Okay. And then they finished the year with a number of tests of the Starship, getting it ready for its orbital flight. And the most recent one was a single engine test of the Starship, testing a Raptor that had to be replaced. And here we go. And here was the static fire as seen from above. And this was only one engine that was fired. You see the amount of power just in one Raptor engine there. Lastly, the problem at the International Space Station. This is what the Russian Soyuz normally looks like when docked to the International Space Station, but this is actually what happened. There's a leak. There was a leak of coolant which sprayed large quantities into space. We're not sure why this happened, but it does look as if it might have been a piece of space debris that ruptured the cooling system on the Soyuz, or it could have been a small meteor. But my money's on the space debris, because as we know, there's a lot of it about. The crew are in no danger on the space station, but whether this particular Soyuz will be operational again is anybody's guess. So Russia are at the moment considering sending up an empty Soyuz to fly at least some of the crew back from the space station. And just to finish with the stats for this year, who launched and how many times? The United States led with 85 launches, of which 82 were successful. China has well overtaken Russia to become the second major launcher with 62 launches and 60 successes. Then you have Russia and Europe, India, Iran, Japan, and South Korea with their launches. As you can see, it's a long way from the days when we just had the United States and Russia launching, as space exploration becomes ever more international with more countries launching. So there you have it. So there we are, guys. That's the review of the year.
Yeah,
Anybody
it was.
those?
Yeah,
Excellent.
it is fantastic. I think the creme de la creme was the James Webb. As we know, it was launched Christmas Day 2021. It gave us a few sort of like sleepless nights as it all unfurled itself, and then it started to do its collimation of all the mirrors, and then of course we heard one of them got dinged by a meteorite, and everybody, oh no, no, no! But luckily it caused very, very slight damage. And ever since then, it's just performed fantastically. And the unfortunate thing is, and I don't want to put a downer on it, is we lost more this year, as in space exploration, than we actually gained for several reasons. And the main one being the Russian attack on Ukraine, because it's surprising how many rocket companies actually have fabrication sites out there of different components. And of course, with the invasion of Ukraine, that all stopped, and it was a couple of the United Kingdom, Skyora especially, were affected. They've managed to work themselves around it, but also we lost the Psyche mission. I'm not sure whether that was to launch this year, but
Yes, it should have launched this year.
Yeah, it was communications between the actual computers that are going to run it and the actual probe itself. When they put it on a test bed to test it, they found that it couldn't be connected to each other, so nothing talked to each other. And from what I last heard is that they were hoping to launch it next year, but I think even that's been pushed back even further now to the year after. But this is unfortunately has had a knock-on effect with other probes that have been sent us. I think it's Veritas that's going to Venus.
Venus.
That's now been pushed back. That's been pushed back also. But there's been several things that have accumulated to basically stifle the exploration that we were hoping to get this year. And unfortunately, while we're at it, I will mention the UK space industry and the government. This year we should have had at least probably one, maybe two, one horizontal launch and one vertical launch on the UK soil, and that would have brought us back in to play with the big boys. If you remember, back in the 60s, we did have our own launch capability, and we gave it up. We're the only country in the world to give it up. So we'll remember that. But we would have hopefully been back in with the big boys. But the government are putting so much red tape in the way of these people who want to use it. And people are clamoring. People are putting in orders that, they say, we want to come and launch here. We want to do this, that, and the other. But the red tape is absolutely astronomical. And the unfortunate thing is there's a lot more countries out there that have islands, and they're snapping people's hands off to try and get the launches that were going to happen in the UK to launch somewhere else. And a good example.
The space program in the 1960s from the UK, basically the government were told space is not profitable.
Yeah.
That's why they gave up the...
exactly.
Absolutely. And I mean, the CAA is the Civil Aviation Authority, is the organisation that oversees all of this. They've got, I think, 389 employees. Only 11 of those employees have been designated to process the licenses from all these startup space companies clamoring to get into space. And they deny that there's any problem. And no, we've got to sort it. It's fine. Don't worry about it. But it isn't fine. Virgin Orbit have been waiting a long time to launch from British soil. It's a big event. The first country in Europe to launch a rocket from its own soil. And you would think that the government would be falling over themselves and moving heaven and earth to get these things processed. But as Daz says, the bureaucracy and the red tape has just got so much.
How much does it cost to keep that 747 on the runway at Newquay?
Well, exactly, at Newquay. Yeah, absolutely. And
And
we're
a
all
good
thrilled about
example
this.
was
Sorry.
a good example was Skyora, which I mentioned earlier.
Yeah.
For them to be able to test their rocket, they had to go to Iceland.
Yeah.
And
Exactly.
unfortunately, the test, which shouldn't have been a test, failed, and that was due to a couple of lines of computer code that were incorrect. They'd done I think if I remember right,
That's all it takes.
well, yeah. I mean, they did a wet rehearsal where they loaded fuel, but then they took the fuel back off again. We're preparing for the launch, and I think they were putting the oxidizer into the rocket, but there was still some fuel from the wet test still there, which somehow through the computers ignited, and they had to let the rocket go. It went quite high actually. It didn't reach space, but then it crashed down into the Atlantic. But that was just down to a few lines of code. It did fly. They did say they got lots of data, which is always the get out. They got some good data.
Yeah.
And also the thing is, they also showed that they could launch from anywhere in such adverse conditions, because the weather there and where they were launching from was in the middle of nowhere. They had to build a road. They took their mobile systems there. They got it all set up, and they did have a launch of sorts. But it was a mistake.
Well, I think on the plus side, though, Britain is leading the world in the removal of space debris from low Earth orbit, and now you may find that a bit of a false claim, but it's absolutely true. 2 companies in the UK have been awarded £100 million over 3 years to seriously study the removal of space debris, which is becoming a problem, as we might have seen with the Soyuz, as I was saying. So Britain is leading. Britain is the only country, seemingly, in the world that is putting its money where its mouth is and actively doing something to design a system for removing space debris. And as a British person, and I'm sure you guys are, we should be proud of that. On the other hand, this week, the American Senate directed NASA to do something serious about the space debris problem, but they also said at the same time, but there's no money for it. So, same old story with NASA, being told to do things, but not being given the money to do it.
And a local university to me, the University of Warwick, is actively taking part in that.
Really?
Removal, yeah.
Well, that's great, isn't it?
Yeah.
I mean, this is the media should be talking about these things and singing it from the rooftops. Britain is leading the world in probably one of the biggest problems facing the exploration of space at the moment, which is space debris, and nobody's talking about it. Yeah. So there we are. But for my money,
I'd just like to ask who are watching. Oh, sorry. No, sorry. I was just going to ask the people who are watching if they've got a favourite event that happened this year. Just pop it in the chat.
Yeah,
and then we can have a quick talk about it.
Ian says it's the bread for him as well.
Yeah, the Dart mission was his highlight. Yeah. So if you've got a favourite, pop it in the chat. We can possibly discuss it. I mean, one of the other things that we did lose due to the Russians and the Ukrainians was the Rosalind Franklin probe that was supposed to go to Mars.
Yeah.
The ESA probe, because that was supposed to be launched on a Soyuz, and of course all glasnost went out the window when it happened. And I've just noticed Stan's put his was James Webb Space Telescope. That's been his favourite this year so far.
With Rosalind Franklin, though, does ESA are looking at alternative means of getting Rosalind Franklin launched. So watch this space, as they say.
And John says again, another winner. JWST producing some amazing images. You're so right, John. And just think what we're going to see this year. And just think of the questions that are going to come up this year.
We're going to need a bigger program.
We're going to need a bigger program. Yeah, we definitely are.
Need a bigger computer with the data we're going to get. Need a bigger computer. Yeah. Also, while we're talking about that, I must mention one of the most amazing and surprising things of this year has been ingenuity on
Of course, yeah.
Yes.
Mars.
Yeah.
And
As far as I
speaking of
understand, I
which,
think that
sorry, go on.
yeah, sorry, carry on, Andy.
No, I was going to say,
Oh, you
speaking of
first.
which, I believe we got some news about that from Michael. So, Michael, I think just to finish today, we'll turn over to you for the normal space news. So,
Okay.
what's going on?
Okay, just bear with me. I'm going to try sharing my screen, actually, Andy. So,
Oh, are you? Okay.
yeah.
Fine. Let me just
Uh,
kill that then.
okay.
Don't forget that once uploaded.
Yeah, I know I'm going to get the right one first.
Okay, good.
Yeah.
It's a bit of a forest of technology here, if that's the right word, viewers. While Michael is sorting that out, oh, he has sorted it out. There we are.
Yeah, I have.
There we are.
Have you got it? Yep.
Yep, that's it.
Okay. So, tonight's What's Up in Space for 20th of December to the 26th of December. Okay. And my first slide is what Andy's already talked about, is the Soyuz MS-22 spacecraft. Investigations continue with that. As Andy said, there was a hole found during the inspection with the ISS remote robotic arm. One possibility it was caused by a micrometeorite hit. Possible problems could be overheating electronics could fail during re-entry, which would be not a good thing for the people inside. Possibility of bringing the next Soyuz launch to ISS early and launch without crew, as Andy said, to act as a lifeboat to bring those astronauts home. And also, I heard that they might even consider using a Dragon mission to bring the astronauts home. Don't know any more about that yet. So that could be a possibility. Okay, and this week, sadly, that we've now lost the InSight Mars lander after more than 4 years of science on the surface of Mars, detecting Marsquakes.
Very sad.
A really good career for InSight. One of the longest running missions after the rovers on the planet, really. So it's unfortunately they tried to contact it twice and didn't get any answer, and they basically said because of that they decided to retire it. So unfortunately, InSight is now dead. Unfortunately. Okay, a bit closer to home. This week, spacewalkers installed the 4th rollout solar array. Josh Cassidy and Frank Rubio of NASA concluded their spacewalk at 3:27 a few days ago, and they're actually adding these solar arrays to produce a lot more power to the ISS by up to 30%. Increasing the station's total available power from 160 kilowatts to 215 kilowatts.
That's a lot of kilowatts.
It is a lot of kilowatts. I thought that was quite a good picture of I've got there.
And they're so much smaller than the old ones, aren't they? It shows how
they are, yes. They're basically attached to the same mounting, if you like, as the original.
They're a fraction of the size of the others.
And they're probably less than a third of the size, something like that.
But you know what that means, don't you? That's going to make the ISS a lot dimmer in the skies.
But they are going to be. Well, I wouldn't have thought so because the original solar arrays are being kept, as far as I know.
Are they? I thought they were going to discard them.
Right. Okay. I'll have to look into that.
I thought it was a straight replacement, and they were going to.
Okay. I'll look into that.
Yeah, look into that. I may have dreamt that. If I did dream that, it's rather sad, of course. But look into that. I think it's an actual replacement.
Right. Okay. I'll find out for next week, hopefully. All right. And the robotic mission that I will be talking about on the next slide is the mission to Titan for the Dragonfly mission. This is the Dragonfly mission, which is the drone, if you like, or helicopter. And this is the testing of the rotor blades for the helicopter in the NASA's Langley Transonic Dynamics Tunnel. So you can see how small the rotors are compared to the people there. So it's not a very big spacecraft at all, but obviously it's going to be flying in the atmosphere of Titan.
Well, you say that, Michael, but a couple of things we should remember that unless they've redesigned it, the Dragonfly itself is about the size of a small car.
Right. Okay.
Yeah. What you have to remember is that, sorry.
I was going to say, actually got eight of these rotors on the actual vehicle.
That's right. And because Titan's atmosphere is such a dense atmosphere of nitrogen, it's not like Ingenuity on Mars, for example, that had to deal with a very, very thin atmosphere, and the rotors had to be really large compared to the size of the vehicle.
Right.
So these, in theory, should be enough to get Dragonfly flying in the atmosphere of Titan.
Okay.
I just hope I'm long enough.
Yeah. So there's 8 rotors in 4 pairs. So each, like you see in the picture there, there'll be 2 rotors working together, and 4 of those sets all together.
Fantastic.
Just as a reminder, on the next slide, this is how the spacecraft will look. You can see the.
Oh, sorry, I missed one.
Yeah, it's okay. The back end of the it is very similar to the Perseverance rover, using some of the same technologies for the power and so forth.
Right.
Yeah.
Got you.
Okay.
Got you.
All right.
There you are. Thank you very much for that, Michael.
The space news.
There's the space news. And there we are. So that just about brings the program to a close. Unless, guys, you want to say anything else before we go?
No, that's fine.
Okay. Apparently, there was a slight crackle on the YouTube sound again tonight, for which we apologise. We tested everything earlier and everything was working fine. Haven't changed anything in the meantime, but apparently YouTube is picking up a slight crackle from somewhere, for which we apologise, and we've got even that problem back again that we had last week, which regular viewers will remember. It is something beyond our control, but we will do what we can, obviously, to fix it for you.
Andy, did you want me to quickly go through the Artemis slides?
Oh yes, I'd forgotten about that. Sorry, Michael. Yeah. Yes, let's have a look at some of the Artemis slides, because this
just remind us on.
Yeah, absolutely. This has been, another highlight of the year. So let's just have a look at Artemis. Let's put that up there like that. There we are then. So this is the, just look at some of the images.
Yeah.
Do you want to talk us through these, Michael? If anything to say?
Well, not really a lot to say, but I just want some of the fantastic images. I mean, that's a magnificent image, that photo. From the
this one here, yes, isn't that a wonderful image? Yeah, that is.
Yeah.
And you're only supposed to blow the bloody doors off moment.
Yes.
When the lift elevator doors got destroyed.
Yeah.
Yeah, I think that should be a lesson to Elon Musk, and so that flame trenches are a good idea.
Yes.
Yeah, absolutely.
One comment I'd like to make about this next picture, this particular separation picture, it reminded me of the old Saturn V movies, where you saw the interstage falling away from the second stage, where the camera was actually inside the base of the stage. Yeah. But this one is actually looking from the outside, because it's on one of the arrays. Yeah. So I don't know if there were any cameras inside the stages on Artemis.
I didn't see any footage from those. No. Excellent. And then we have the orbit, the flight path, of course.
Yeah.
The Artemis did release 10 CubeSats.
Yeah.
Out of which I think only 3 are working.
Right.
Which is a shame, but this is the nature of the game.
Interesting. The cryogenic stage if you look at that diagram, it was actually sent around the moon to a safe orbit. I suppose because it was rather big.
Yes, indeed.
And also, it created a new record for a human-rated capsule.
Yes,
to
that's right.
That's right. Earth.
Yeah.
It's an orbit that they won't be using on Artemis again, though.
No.
Yeah, that's right. It's actually surpassed the distance reached by Apollo 13.
Yeah.
Yeah. Stan, thank you so much for your comment. Much appreciated. We do enjoy bringing the viewers' images to you. Unfortunately, Rachel couldn't join us tonight, although she is in the bath on the chat. That's the last thing I heard. But she couldn't join us tonight, so we will return to the viewers' gallery next week, of course. So please keep your images coming in. Anyway, moving on with this.
Yeah, that's a good picture of the flight control room for Artemis. A number of computer screens they've got there now, and various other devices.
Well, by the way, while you're on the subject of flight control rooms, I was watching a really interesting video from a YouTube channel called Launchpad Astronomy last night, where they took a tour of the James Webb control room.
Oh, right.
Check that out on YouTube. If you just search YouTube for James Webb flight control room, I'm sure you'll find it immediately. Really interesting video. It's about 20 minutes. And it shows you where they actually control the web from and where the data comes into. So that's worth seeing. Sorry, I just thought I mentioned that before I forget.
Yeah. Just a matter of interest, looking at that picture there, is that telemetry control where they say pointing?
No, it's where they sit. It's where
that's the navigation. That's the navigation system, is it?
Yeah, that's right. No, it's where they sit the freaks and point at them all day long. So yeah. So, yes, that's the navigation bit. Yeah. So there we are. Great.
You'd have thought they used the word navigation, wouldn't you?
Yeah, but they didn't have enough money for it. The size of the site is limited.
And it used to be GNC, guidance, navigation, and control.
Yeah, it did used to be, didn't it? Yeah.
Yeah.
Now it's just called pointing. Pointing.
There's Moonikin.
There's Moonikin, Captain Moonikin, the dummy. I'm not insulting somebody. That's literally what he is. He's a mannequin.
It looks a bit cramped.
Whatever.
It looks a bit cramped for 4 people, though.
Do you know? I was thinking that it doesn't look that much bigger than Apollo, and I thought it was meant to be miles bigger than Apollo.
Yeah.
But there we are. Perhaps it's just the lens.
Yeah.
Yeah. So that was a lovely image of the moon.
Yeah, it's one of my favourites.
Lovely, one of my favourites too. This one of Orion, Moon, and Earth was lovely as well. Beautiful.
That is my favourite.
Yeah. It's a shame that they can't expose for the stars as well. Can you imagine that against a starry background? That would be stunning. But as we know, you can expose for bright things in the picture, or you can expose for fainter things like the stars, but not both.
I could put my one of my images in the background there if you like.
Yeah, do that. That'll be fantastic. Yeah, send it to NASA. They might even buy it off you. Who knows? So this is a lovely close-up, isn't it?
Yeah.
Beautiful.
Oh, Ian's put a note on the chat saying there's a video on Honeywell YouTube channel about sampling sim systems on Dragonfly. So,
right. Thank you so much. Thank you so much. Yeah. Ian's put a link there as well. So thank you for that, Ian. That's in the chat. So there we are.
He's corrected that to Honeybee, not Honeywell. Honeybee.
That's
Honeybee. Yeah. So yes. So we'll look up the Honeybee channel. Definitely. Thank you so much.
I thought that was my local pub.
Yeah, you would. Next. Right. So again, a lovely image of the Earth. The Moon. Taken from one of the arrays on Orion. And then we have. Oh, sorry, I didn't mean to do that. Then we have the splashdown, of course, when that went off without a hitch and perfectly on trajectory, apparently. And it proved that the long skip maneuver, where they sort of skipped over the atmosphere to reduce stresses and heat on the spacecraft, worked like a charm. Never been tried before, so that was something they'll be doing in the future, because it really does subject the spacecraft and the astronauts to a lot less pressure and heat and everything else. So that was great. And then we have the recovery, so with the big balloons. So there we are. So thank you very much for that, Michael. Very kind for putting you together. Okay, guys, we will say good evening. Thank you so much for being here. Thank you for your kind comments.
Can I just mention two big events that are happening soon?
Of course you may. Go ahead.
You've got the Practical Astronomy Show in March. I've got no details on that. That's been flagged up.
Where is
there's
that?
Also the Euro Astrofest festival, which is in February. Between the 3rd and the 4th, there's lots of talks that you can visit. But if you want to just visit the trades hall, you could buy a ticket just for that. So there's two big events coming very soon. They're both being visited by the Society for the Society of Popular Astronomy, and also Rother Valley, our sponsors, will be there. So pop along, have a word with them, tell them you're Space Oddities fans, and
they'll hit you.
You
may
even see your Space Oddities. Sorry, mate.
Where are those events happening? We're held with
I'm not sure about
the European Astrofest is in Kensington, in London.
Right.
Yeah, it's in the Kensington Conference and Events Centre. Right. And as I said, it's the 3rd and 4th. Tickets can be bought online through Astronomy now.
Yeah.
Practical Astronomy Show is up at Kettering on the 11th of March.
Kettering, there we are.
Oh, different.
Thank you, Roger. That's great.
So you can go to the races as well.
Yes.
Yeah. Go to the races as well. Okay, thanks for that, Daz. We will, of course, keep you up to date with any other astronomical events that are going on. And if you're a society and you've got an event, we're more than happy to publicise it for you. We would obviously, like to get involved with you astronomy societies out there and see if we can do anything for you in terms of publicity. So, if you've got a particularly good event coming up that you'd like us to tell people about, please let us know. And you can find us at spaceodditieslive@gmail.com. That's spaceodditieslive@gmail.com. Thank you to Astronomy Ireland for letting us invade their page on Facebook. Thank you again, guys. Always much appreciated. And thank you to those of you who have been watching both on the Astronomy Ireland page and on our Facebook page. And, of course, those of you out there in YouTube land. We do appreciate you all being here on Boxing Day. It's much appreciated. We wish you a continuing fantastic Christmas. Don't get too sober. That's always a big mistake. And we will be here same time next week, 8 p.m. UK time for our normal Monday evening show. So do you want to say goodbye, panel?
Goodbye,
panel.
Goodbye,
Happy New Year, and we'll see you in the new year.
Yeah,
2023.
2023.
Oh, that's right, 2023 coming up. And what a great year in astronomy and space it's going to be. And we shall look forward to sharing everything with you here on Space Oddities. So from all of us here and everybody who isn't here today, and we'd just like to say thank you for your support in 2022. And don't forget to hit the subscribe button. That's really important to us anyway. It may not be to you, but it is to us. So give us a break. And we hope you're going to continue to join us here on Space Oddities in 2023. But have a lovely time with your family and friends. And from all of us, it's goodbye. Bye.